Welcome to another instructional video on integrals of some common trig functions. Here we'll look at the integral of sine cubed theta d theta. This is very analogous to the previous video that we did on the integral of cos cubed theta d theta. We will treat this particular video as if you hadn't watched that one, but if you have watched that, then my apologies to you up front because it's almost the same sort of thing, just very small, slight differences. Okay. We begin by rewriting sine cubed as sine of theta times sine of sine squared theta d theta. And then we notice that this is the integral of sine of theta times, now sine squared theta plus cos squared theta has to equal 1, so I can rewrite sine squared theta as 1 minus cos squared theta d theta. Okay, that's just the basic trig identity. And as I mentioned in the previous video, there are essentially two ways of looking at this, basically the same thing, but two different ways of looking at the same thing. It's two slightly nuanced ways of looking at the same thing. So let's go ahead and split the page into two parts, and I'll show you each of them like I did in the previous video. So on the left side of the page, we'll show that, and we'll do this by u substitution. So if I say u is equal to cos of theta, and I'm looking ahead and looking at this cos theta as cos squared theta as cos theta being squared. Okay, it's the same thing. Then, if I let u be cos theta, then du is equal to minus sine theta d theta. Okay, so now let's go ahead and write this. So we're going to distribute the sine theta in here. Okay, so I'm going to get this is equal to the integral of sine of theta d theta minus the integral of sine theta cos squared theta d theta. Okay, and so then I find that this is equal to, of course, the left integral is very simple to do. It's just minus cos of theta. And then notice in the right integral, I have the minus, I have a sine theta, and I have a d theta. And all of that is just equal to du. And moreover, we looked ahead and we said, let's write cos squared theta as cos of theta being squared. So all of that to say that I get plus, okay, I'm going to, all this stuff that I've circled in the red, minus sine theta d theta, it's all equal to du. So it's really the integral of, and cos theta squared is just u squared, so it's u squared du. Did you see how easy that was? And so, well, we're basically home at this point. We just, that's a very simple integral to do. So we have from the first integral minus cos theta plus u, the integral of u squared du is a third of u cubed. So we get 1 over 3u cubed, plus we pick up a constant of integration, and this is equal to minus cos theta plus a third. We'll now sub back in for u, and there it is. U is cos theta here, so it's cos cubed theta plus c. Okay. On the right side of the page, let's kind of look at this as we did in the previous video. Again, this is a nuanced way of doing the same thing, so whatever you prefer. Okay. What I could do is I could say, let's write the differential d, instead of d theta, let's write it as d cos of theta. And if I do that using the chain rule on this, so the d of cos theta is going to be minus sine of theta. And then the chain rule insists, of course, that I'm going to also take the derivative of the argument there, so that's going to be d theta. And that should look familiar because that's what we were calling du on the left side of the page. So all of this integral here I can write this way. I can say I've got the integral of, alright, now one thing I'm going to do, let me do this. Let me multiply through by a minus, so I'm going to have minus d cos theta plus sine of theta d theta, and that's this stuff here. Okay, let me see if I can grab that stuff here. There it is. Okay, so that's all that. So I've got all of the stuff I just bubbled there is minus d cos of theta, and then what I have in this parentheses is 1 minus cos squared theta. Okay. Now notice that I'm doing the integral not with respect to theta anymore, but with respect to cos of theta, which is great because I have a cos. I'm going to write this cos squared theta as cos theta squared. It's the same thing, right? So this is equal to minus the integral of 1 d cos theta is just equal to cos theta. Okay, and then minus the integral of minus cos theta being squared d cos theta, that's a plus. The cos, of course, becomes cubed over 3, so it's a plus 1/3 cos cubed theta, plus we pick up a constant of integration. And notice that the left side of the page and the right side of the page match. Okay, so that's all good, well and good, and it should. If you're doing the algebra right, everything should match up. Now, as we did in the previous video, you may possibly see this expression shown slightly differently in a textbook, possibly. So let's also check that out real fast. So I can say, or another way that we can express this is to say I have a cos theta in common. So let me pull that out. And in fact, I'll pull out a minus cos here. Minus cos theta is going to be 1 minus, inside of there I get a third cos squared theta, and then I'll leave the constant out of the bracket, and this is equal to minus cos theta. And once again, remember that this cos squared theta is nothing other than 1 minus sine squared theta. Okay, so if I do that, I get inside the brackets I get the 1. I get a minus a third times 1 is a minus a third. Then a minus a third times a minus sine squared is a plus third sine squared theta, close bracket, plus the constant of integration. And then 1 minus a third is 2/3. And so I get minus cos theta, open bracket, times 2/3 plus a third of sine squared theta, close bracket, plus the constant of integration. And then lastly, I can say that this is equal to, let's pull out a common third here, minus a third of cos of theta, open bracket, 2 plus sine squared theta, plus a constant of integration. Okay, so this is another way that you may see this result written, and so let's summarize. Therefore, the integral of sine cubed theta d theta is equal to minus cos of theta plus a third of cos cubed theta plus a constant of integration. Or equivalently, we can write this as minus a third of cos theta times 2 plus sine squared theta plus a constant of integration. And there you have the result for the integral of sine cubed theta d theta. Thanks again for your attention, and we'll see you in a future video.